My name is Bobby Siapanya. Uh, my role was the product designer. Um, I was also the researcher as well as the design document author. Um, Here we have the design matrix and the properties that I chose to put on the design matrix were buoyancy, availability, durability, and cost. I chose buoyancy because our product is a boat, and if our product doesn't float, then it's not a boat. It's a rock, basically. And I put a weight of 5 on there because it's very important that your boat can float. Um, the next property is availability. Availability is just there so parts were easily replaceable if something were to break. Um, the next property after that is durability, and it had to be durable because the boat would be in weather-like conditions, like it would be getting wet, sometimes it'd be dry, it'd be hot. I feel like this was very important too because it needed to hold up after long time use in the rain or on wet surfaces. Uh, Another important property was cost because we were set with a $100 budget, and if we wanted to go over that budget, it would have to be money out of our own pocket, and everybody likes free things, so cost was very important to us to keep the cost low so we didn't have to spend any money. Option one was made out of cardboard for the durability. We got a low score because it does float on water and it is available for cheap, but cardboard over time, when it sits on water, starts to get soggy and very malleable. Option two was a boat made out of paper. This one's kind of obvious why this one had a low score as well. Paper doesn't last very long on top of water, even though it is cheap and it does float on top of water. Option three ended up being our best option, which was polystyrene foam. Uh, because it scored high on the design matrix, it's what we ended up going with. And polystyrene foam is basically styrofoam. Uh, it floats on water because it has multiple air pockets inside it, and it's also very easy to obtain, and it's cheap, and most of the time you can buy it in bulk. Um, and it doesn't really lose any durability to water because it's virtually hydrophobic.
My name is Timmy Ussery. I was the team representative and I was responsible for the PowerPoint, creating and maintaining that, and then one of the co-builders of our project. Our company is named Vesselcraft Industries and our product is named the Soul Boat. The Soul Boat will be a small boat made of foam that has a motor and a propeller, and it's powered by a solar panel. It also has a backup battery if the solar panel were to fail or not to provide enough charge. We wanted to construct something simple that would show visually how easy it is to generate power from the sun. And we were thinking just with the solar panel, a lot of our team members wanted to work with solar panels and learn more about them. And we just wanted to show how beneficial this can be for both small scale products and larger scale. Um, so we thought this would be a simple method of teaching people just how easy this can be.
Hi guys, so my name is Diego Camacho. My role was drafting engineer and co-builder. While building the product, we all agreed that our target audience would be everyone interested in toy boats or toys overall. The product would be suitable for kids as well as teens or even adults. The one thing we would do differently if we were to have a final draft would be to have a remote control kit powered by a single solar panel. That way the power output and the control over the product will be totally manual. Alright.
Hi, my name is Arida Yarajo, and I am one of the co-builders for Vessel Craft Industries. Now, when working on the solar panel, on the soul boat, we were very excited to be working with solar panels, and there was a lot of research that we put into learning about solar panels and how they function. Now, I'm going to show you the first day and how it looked like. So, of course, we did make our boat out of styrofoam. It's light and it floats, and so it is cheap. So it checked all those areas. And so here we have the solar panel. Now the solar panel will collect energy, and then it will store it into the batteries, and it will help charge them. Now the batteries will then help turn on the motor, and then it will turn the propeller, making it spin. And here we have the switch, which helped control when we had it, will help control it and turn it on and off when we need it to. Now, here is the second day draft. Now, by this point, we had wrapped our boat. We did come to a problem of the boat because it is made out of styrofoam. So there were times where the edges would deteriorate because, again, it was made out of styrofoam. And so we wrapped it so it could keep its shape intact. And as you can tell, it is a little bit bigger here. We still kept the same design. The only difference is that we put the motor from the edge of the boat closer towards the middle, but yet still kept it slanted so that the propeller would work and be in the water. Now, here is what we thought was going to be our final product. By this point, it was working fine. It was just so neat, and it was working. Now, we came to a problem, which was that as soon as the propeller would hit the water, it would stop spinning. So this made us very anxious. We went back into researching everything, going back through our notes, seeing if we missed anything. And so we had many theories of why it wasn't working. We didn't know if it was the propeller, if it was the shape, if it was the material it was made out of, because it was made out of plastic. If it was the motor, if the motor wasn't strong enough, if the solar panel wasn't collecting enough light or energy, if the batteries didn't have enough energy. So there was just so many variables of where it could have gone wrong. Now, in the end, we did again keep the same shape of the boat. We still kept it wrapped. Now, what we did learn was that on the original motor, as you can see right here, it was like about 1.5 volts of power. And so we did have to go purchase another motor. This one did come with two different motors. As you can tell, we placed one here in the front, here in the front and here on the bottom, on the back. They are 3 volts each, so it was a lot stronger, and so when the propeller hit the water, it wouldn't stop spinning. It still had some force, and we did try putting them on the edge, both of them. Only problem was that whenever we placed the boat in the water, it would spin to the right and it would just keep going in circles. So at that point, we were excited it was working, but we were still bummed out that it wasn't going at least in a straight line or forward. But so that's why in our final product, we did keep one here on the bottom or on the back and one in the front, and it did help move the boat forward in a straight line. And as you can see, we did put two solar panels, excuse me, and 2 different sets of batteries along with 2 switches on each end. And that just helped create more power for our boat in the end. So one thing I did forget to mention was that not only was the test to see if it would work in the water, but the other test was to see if it could go the distance of 2 feet. So that's what you're going to see in our final test video.